This presentation covers the manufacture of light steel framing. Light steel framing uses two-dimensional wall panels that are assembled in a jig for dimensional accuracy. The C-sections in the walls are known as studs and are typically 70 to 100 millimeters deep. In a wall panel, the top and bottom C-sections are known as tracks. The steel thickness is generally the same within one panel, but can be varied among a number of panels on the floor depending on the loading applied to them. Connections are made by screws, rivets, clinching, or small diameter countersunk bolts. In a given wall panel, doors and windows are detailed as structural openings, and they have single or two or three C-sections next to the openings, depending on their size. This photograph shows a factory producing light steel sections that are roll formed from coils of strip steel, and you can see here in the middle ground the coil of strip steel waiting to be placed in the roll forming machine, and along the length of the building the C-sections are roll formed by up to 20 different roll forming stages. You can also see the coils of strip steel that are ready to be placed, and each coil is cut to the correct width for a given C-section and also of the correct steel thickness. The wall panels are assembled in a jig for dimensional accuracy, and in this case the connections are formed by clinching, in which the tool is supported from overhead. Small-scale roll-forming machines can also produce two-dimensional panels, in this case for 70 mm deep C-sections. Light steel framing is specified based on its thickness, typically of 1.2 to 4 mm thickness, including the zinc coating. The steel grade is specified as its yield strength in units of newtons per millimeter squared or megapascal, and typical steel grades are S280 to S450. Strip steel is supplied to a BSEN standard 10346, and the basic shapes are C-sections for walls and Z-sections to support floor joists as shown here. Building Information Modeling, or BIM, is key to the whole design and manufacturing process. The architect supplies electronic versions of 2D or 3D drawings with the basic geometry of the building, and it's the role of the light steel supplier to transfer that information to produce a 3D model of the whole building structure, which is delivered back to the architect and to the main contractor to check for clashes and interfaces with cladding and services, for example. The light steel supplier, having then agreed the 3D model with the architect, produces two-dimensional panel drawings that are linked to the manufacturing process through computer numerically controlled machines. The 3D model may be used by the contracting team for the sequencing of construction, and when the building is completed, for facilities management, and this is known as BIM Level 2. So here we see a 3D model used in manufacturing in which all of the components is defined, and that would also include the hot rolled steel components such as beams and columns, the precast concrete stairs, and often the facade elements. Floors use C-sections that are typically 150 to 300 mm deep, depending on their span up to about 6 meters. Floor joists are generally placed at 400 mm apart, but sometimes up to 600 mm spacing, depending on the rigidity of the boarding that's used. Joists are supported by Z-sections placed over the walls and by angle cleats with screws or bolts. Floors can be prefabricated in the form of cassettes that are placed on the wall, or are built with Z-sections that are placed over the wall. Composite decking may be used as an alternative with on-site placed concrete, although it is much heavier than joisted construction. Here we see a typical cleated connection of joist to a Z section placed over a wall panel, in which the number of screws is dependent on the loading applied to the joist. Here we see installation of a large prefabricated floor cassette, in this case of the order of 4 meters span, in which the C-sections have preformed holes for servicing, and you can see in the foreground the bolt holes used to connect the panels together, and also the bolt holes in the background used to connect to the external wall panel. Bracing is built into the panels to provide in-plane resistance, particularly to wind action. X-bracing is in the form of straps of 40 to 100 mm width, which is fixed at the corners of the panels. K-bracing uses the same C-sections as in the wall and is often used between the studs around windows. X-bracing only acts in tension, whereas K-bracing can act in tension or compression. Lattice bracing can be built into the wall panels over long windows to act as a lintel. Here we see a good example of X-bracing produced as part of a wall panel. In this case, it is a double leaf wall that's used for a separating function between two apartments, and as you can see, the bracing is contained in the space between the C-sections. Integral K-bracing is often used around openings and lattices over openings, particularly large windows, and we can also see here the use of double C-sections above and below the windows and triple C-sections to either side. Tolerances are very important in the manufacture of light steel framing in order to accommodate inaccuracies in other elements of the construction. Light steel wall panels, for example, are often manufactured slightly shorter to allow them to be connected together without growing along the length of the building. Ground floor wall panels in particular are manufactured up to 5 mm shorter so that they can accommodate upward variations in the foundation or slab level. Joists again are manufactured slightly shorter in length to allow them to be inserted between the walls. And structural openings also are detailed to be up to 10 mm wider than the actual opening width. So what are the learning points in the manufacture of light steel framing? Firstly, wall panels are produced in a jig, with C-sections that are spacing to suit the applied loading and openings such as windows and doors. X or K bracing is included in the panel manufacture for stability. Panels are made 3 mm shorter in length and 5 mm shorter in height to allow for dimensional tolerances, particularly of ground floor slabs. Floor joists are supplied cut to length, up to the correct length, but with holes for services if required. Manufacture of floor cassettes speeds up installation on site, but requires a more regular plan form to be economic.